Welcome to Teach a Course class. This class is being designed to assist NATED engineering students from TVET colleges. Today we'll be focusing on Engineering Science N3, and our topic is moments. Today we are doing Unit 2. Unit 2 will cover the following objectives: UDL, shear force, and examples. UDL, which simply stands for Uniformly Distributed Load, is a load that is uniformly distributed along the length, or part of the length of a beam. A UDL should not be confused with a point load because it is not concentrated at a specific point but is distributed for a certain portion on the beam, sometimes throughout the beam. A UDL is allowed to act as a point load only if you are calculating reactions. If this is the case, a UDL will have to be positioned to the center of its distance before calculations can take place. On this example, we are requested to calculate the supports whereby a UDL is distributed evenly throughout the beam. Remember, when calculating the reactions and the UDL is present, first thing first we need to make the UDL a point load by placing it at the center of its distance. Take note that the total length of the beam is 10 meters, that means the length of the UDL is also 10 meters since it is distributed evenly throughout the beam. Let us start by converting the UDL to a point load by multiplying its given value by its total length. Then, let us place it at its center of distance by dividing its length by 2. Now we can see that we have a point load which is 100 newtons 5 meters from the left-hand side and 5 meters from the right-hand side. For us to calculate reactions is to use our methods we learned from Unit 1 by introducing a fulcrum. Remember to always verify if your system balances after calculating reactions. Shear force is the force in the beam acting perpendicular to its longitudinal axis. We will use shear force diagram to determine the point of maximum bending moment, although bending moments will not be covered on this level. At this stage we just need to understand how do we draw a shear force diagram, and more inner depths of the shear force will be explained on N4 level. A shear force diagram will have the positive and negative margins determined by forces. The reactions will be positive forces due to their direction and point loads, and UDL will be negative forces. When drawing a shear force diagram, always try to start drawing from left to right. This example does not contain any UDL. On this example, you will notice that there is a UDL present throughout the beam, hence our shear force diagram is slightly different compared to the previous one. This is a much complicated example. A UDL is not distributed throughout the beam but only for 4 meters from reaction B to reaction C. Even if this is a case, for us to calculate reactions we need to convert the UDL to a point load and place it at the center of its distance. The center distance of our UDL will be 4 divided by 2, and its magnitude as a point load will be 10 kilonewtons per meter multiplied by 4 meters. After converting the UDL to a point load and placing it at the center of its distance, we can therefore continue to calculate our reactions normally like we have learned in Unit 1. After calculating the reactions, we have to verify if the system is balanced before we continue to draw a shear force diagram. Remember, when drawing a shear force diagram, always start from left-hand side to the right-hand side. Before you start drawing a shear force diagram, remove the point load converted from UDL and put back the UDL to its original position with its original magnitude. Thank you for watching this video. Don't forget to like and subscribe for more videos on shear force diagram solutions. If you have any questions, feel free to leave your questions on comment section.